Good morning everyone, it's Francis. We're here for another collision course and we have a full plate of topics to talk about. Let's talk about first the Earth. Now you notice that a lot of my drawings are already drawn today because I had some input as to my whiteboards and someone said it could go a lot quicker if I pre-drew them. So let's see how this works and then I'm going to get your feedback to see if it works or if this is not what you want. But today's collision course for November 21st talks about 2011 WN2, a near-Earth object that is 30 meters in diameter. We're going to talk about 2011 WP4, which is 15 meters in diameter. We're going to also talk about 2011 WQ4, which is 11 meters in diameter. These are all the objects that we're talking about today. I was alerted over the weekend to this one right here. And when I went and did the research on 2011 WN2 at 30 meters in diameter, we discovered some more. So why just do one? Let's get them all in there. We're going to go all the way to, as of this current update and what is known, what I know. And please take into account this is my own research. You all know that I do my own research. I am not associated to a scientific body. The only bodies I am associated to is my wife and my son and my family. Other than that, this is all amateur astronomy, and I hope that you take that into consideration if there is a reason to nit or pick. Okay, here's the Earth. In the diameter, or its distance across from one side to the next, 12,756,200 meters. I did this because somehow I wanted to give the appearance or give the listeners and viewers like yourself an opportunity to see somehow some sort of size range difference. This is not to scale. There's no way this is to scale, except I just used it in my head. 2005 WQ4, it just went by, was 204 meters across. I got that number after doing some more research today. That was one of the readings, the size that they were confirming, and it came within 195,000 miles of Earth. WQ4 was approximately 63,000 times smaller than Earth. If you did the numbers, I did them in my head. It appears that this asteroid was 63,000 times smaller than Earth, and we ended up with a close pass of WQ4. And so the reason why I try to do this is I try to keep in my head visually the scale of these objects and the closeness of these objects, because I learn about all these objects in the same way. Oh my God, have you seen? 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 Somewhere in all this information, there's no four oh my gods. There's one oh my God maybe, and then let's do some more research. Are they doing research? What's going on? But there's more interesting things to these because there's more interesting things. So I don't want to discount that. But for me personally, oh my God, oh my God, oh my God, oh my God, is 3 oh my gods too many. WQ4, we already passed 195,000 miles to Earth. The next one in size from that, and this is not date order, this is in size order, 2011 WN2 30 meters. I did the numbers, and I came up with a close approach of 1.9 million miles from Earth. It's 6 times smaller than approximately than WQ4. These asteroids have orbital paths that have not been inspected or viewed for an enormous amount of time. I can tell you though that the observations that have been made have come with the background stars and that they are flying across. The scientists who know mathematical astronomy can gauge the exact location of these objects, and from even just a few number of images which put the object in different places, can they determine their orbital paths. I'm sure, even though these are brand new, or the ones that are, will continue to be observed, but it doesn't take much to triangulate an orbit from images that give you triangulation points. Oh my God, we don't know where it's going to be, and I look at this distance, and if this distance is correct, and my research is correct, this is, well, what do you want to say? That is, how many more zeros? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. That is 10 times greater than this one came in. So let's say this is off, and it's smaller than WU55, and it's off. It still has 10 times. It has a lot to go off before it even gets here. And then if it gets here, we look at size of the objects, and but again, maybe the size isn't confirmed either. I think I did catch a side note that they, but that's what they have for the size right now, so that's the research I could do and what I'm going with. 2011 WP4 is a 15-meter near-Earth object asteroid, and it's coming to within Earth of 353,232 miles. And again, we compare the closest one that we just got by and where some of these other ones resist. This distance is greater than the average distance of the Earth to Moon, the Moon to the Earth. And then 2011 WQ4. I may be missing a whole. I may be missing a whole asteroid here. I guess that's why we have a pen, though. Get that. See, I missed one in the middle. And we have 2011 WQ4, 11 meters, coming to within 474,075 of Earth. We have one more here. I guess this is where I go, and we'll put it right in here because we're doing size, and that is 2000 YA. That is 63 meters, so compare this. Let's go from here, go a little bit smaller, a little bit bigger. 63 meters. And its closest approach is 687,873.6. There's lots of varied distance here. We go in size, because we're going to talk about this also. 2005 YU55, 204 meters. 2000 YA, 63 meters. 2011 WN2, 30 meters. That's how close to what we have to check that. We have to keep our eye on that distance. And then we have these and these. And also, these also have varied certainties on their orbit, which we're going to pay attention to. I want to look again. Yeah, WN2 comes 0.210, so that's why it's so far up. 0.210. The WP4 comes 0.0038, and then WQ4 comes 0.0051. Okay. Let's move on. Let's see what else I have already drawn up. Try to remember the scale, though, what we're talking about. Okay? I think it's important. I really do. As far as, oh my God, oh my God, oh my God. But I can't tell y'all how to feel. So, oh, look at that, stopped right there. We're going to just go over these, and the reason why I did it like this is because I wanted to show you where the general direction from where these objects are coming from. You can assimilate any similarities or not. You'll notice that my angles, this thing right here, are exaggerated. They are exaggerated just to prove a point of where the object's going to be in relationship to the ecliptic plane, which is where the Earth rotates around the Sun. 2004 WQ4 at 11 meters shows up tonight to Earth. 22:53 UTC. I'm minus 6 hours, so that's 10 o'clock. So about 4:53 this afternoon, or about the time this video is going to be online and live this afternoon in Texas. 6 hours behind this. 6 hours behind this at just about 11 o'clock, so just about 5 o'clock this afternoon. 2011 WQ4 at 11 meters across is going to come to then 0.0051. 474,000 miles. And then from the moon, about 10 hours later. So 5 o'clock at night, 3 o'clock in the morning, it's passing the moon. And if we were looking from the sun, the path of the asteroid came from up above, and before it reached Earth, it actually got below the plane. Now again, this is a misrepresentation because I made a harsh angle rather than a more true literal angle, but we have an asteroid that came from above the ecliptic, and is passing below. When it gets to its closest approach to Earth, it'll be below the ecliptic and below the Earth, or at an angle that is below both the moon and the Earth. Just going to let you look at that. So today, about 5 p.m., there's an asteroid 2011 WQ4 11 meters coming by Earth at about 474,000 miles. That's almost twice the distance, or a little bit like twice the distance of the moon to Earth. So it's a pretty big distance. Even if there are some variables there, you do have a pretty big distance, and you have a small size. So that's what we're looking for, and that's, if we get reports of something going on, this it is. But again, I want you to look at this, because this is the research that's coming out when you put all these together, and whether somebody creates a reason, I don't know, but we're going to keep going on. And that's the next one. So now we're in time. What's the next one to pass, and where is it? This is today. It's coming. But it's coming within 474,000 miles, which is twice the distance to the moon, on average. Next, 11:24. 11:24. WP4 at 15 meters. 11:24 Earth at 8:03 UTC. I'm back 6, so it's 2:13 in the morning on 11:24 for Texas. Comes within 0.038. That is 353,000 miles, 353,232. About 353,000 miles away from Earth comes 2011 WP4 on 11:24 on Thanksgiving at 2:13 a.m. In Texas. And then later that day, 9 hours later, at 11 a.m. it passes the moon. So about when I'm going to probably be having or getting ready to be eating my Thanksgiving dinner, right here, 1723 UTC, it's about 11 o'clock. In Texas, hungry, it'll be passing by the moon. And again, this asteroid's general direction took it from above the ecliptic plane to below the ecliptic plane. So when it passes Earth at its closest approach, it'll be below. This is not a perfect drawing of where it will be, but I wanted to make a representation that all these asteroids, these 3 of them at least, are coming from over here, coming from up, coming from below. And then the last one comes from below and comes up. There's the date. Looking from the sun. That's a harsh angle, way, way harsh. I'm sure the computer animations will make that look a lot different, but I'm just trying to get a general gist that the last one came from above, going below. This one's coming from above, going below. What I'm thinking in my head is, are these pieces of a similar object? I don't know. I haven't gotten any reports. I have no idea, but I know that 3 out of 4 are coming from the same place, give or take. Same trajectory towards Earth. Whether they share the same part of space or not, I'm not entirely sure. I'm just bringing up these similarities. And now 2011 WN2, 30 meters, 1125. What do I have? WN2. That's all I have is this one reading. 2011 WN2, 30 meters. Comes within 0.1210. That's the 1.9 million miles. That's 1.9 million miles. That's one of the farthest ones away that we're looking at. I think this is the one I was had the attention brought to this weekend. And again, it has an orbit that apparently to JPL is uncertain. But we have that distance is 1,952,073 miles. 1,952,073 miles is the listed close approach to Earth at 20:01. So that's 8:01. So that's 2 in the afternoon on Friday. That's Black Friday, shopping, people will be shopping, and 2011 WN2 at 30 meters across will be whipping by Earth, 20:01 UTC. It's about 2 p.m. on Friday, 1,952,073 miles. Again, WN2 has a trajectory. Started off above the ecliptic and coming to below the ecliptic when it arrives, when it makes its closest approach. I'm sure that my friend T-Bar, hopefully, will get on these and show us what the computers actually show us, because the computer shows us a totally different thing. Again, my angles are repeating just because I'm bringing up the notice that these asteroids start from above and come from below, and they're all reaching the points, similar in nature. It's catching my eye for whatever reason. I have no knowledge of why, but we're going to keep researching it. But there's your numbers. 1125 to Earth. 0.0210 is 1.9 million miles. 20 UTC. I don't think I have very many more here. What do we have? Do we have anything else? Oh, what do we got? Yes, see, I forgot YA on the first page, but here it is. And this is an Asteroid 2000 YA, 63 meters. So this is the bigger one of the bunch. Not as big as YU55, nor as close, but it is a bigger one. Its trajectory comes from below the ecliptic and reaches Earth going above, and reaches Earth above. December, this is Sean's birthday. Christmas is a Christmas pass. Christmas 2011 to the Earth, 5:43 UTC. So see now, I'm actually getting it on the 12:24. If it's 6, and I'm going 11 p.m. in the U.S. 11 p.m. Texas is 11 p.m. 12:24, Christmas Eve. 63 meters. To Earth, 6.0074, 5:43, and then to Moon, 6 hours later, give or take. And now you can look at some of these times that it gets from Earth to Moon, but longer in distance, but you really can't tell, it doesn't determine speed by how fast it gets to the Moon if it's passing the Earth first. according to where the moon is located. But Christmas Eve for me and Christmas Day for everyone in UTC land, 2000 YA 63 meters, 687,873 miles away from Earth, and then 706,484 from the moon. I think most relevantly, that's the information that you want to hear from me. If there's anything I can add to that, is I thank you for watching the whiteboards. Eventually, I'm going to get to what's behind the to the paper whiteboard, to the dry erase whiteboard very soon. I do keep all the paper, I keep all the art and all the drawings, and I have them saved for posterity. If you have any questions about these diagrams, about what I'm saying, you can leave a comment or ask me a question. Every Friday night I do a Collision Course weekly astronomy report on freedomslips.com Revolution Radio. I welcome you to come every Friday night from 8 to 10 p.m. in New York to listen to what we're talking about, which is the most relevant news about asteroids, near-Earth objects, comets, failed space missions like the Russian-Chinese failed space mission Phobos Grunt. And I'm going to go ahead and end this. Y'all have a great afternoon. How you doing? And we'll talk to you soon. Let me know what you think. Let me know what you want me to talk about, and I surely will do that. We'll talk to you later. Bye.